Welcome back to our 2D character controller series. In today's episode, we are going to be exploring how to create AI for our enemies. By the end of this video, you'll be able to watch your enemies patrol the area you place them in. Link to the full project in the description. Before we dive into the AI, let's take a moment to make some important improvements to our code. A community member pointed out a flaw in our jump script, which we need to address. He noticed that if we change the upward movement multiplier, the actual height of the jump changes as well. This isn't what we want. We want the upward movement multiplier to affect how quickly the player reaches the desired height of the jump, not the height itself. To fix this issue, we'll multiply the upward movement multiplier in the jump speed formula. This will allow the actual upward movement multiplier to be taken into account during the calculation. So when we change it, the jump speed changes accordingly, but the jump height remains the same. The next issue we need to tackle is a dependency in our move script. The wall stick region in our move script requires data from the wall interactor script, but if we try to run the game without the wall interactor attached to our character and touch a wall, we'll get a null reference exception. To solve this error, we need to cut the wall stick region from the move script and paste it into the wall interactor script, between the wall slide and the wall jump regions. Then remove the wall interactor object, since we are already in the class using it, and cut the variables related to the wall interactor from the move script to the wall interactor script. However, this creates another issue. Now that both the move and wall interactor scripts modify the player's X position, we can't stick to walls, because the character gets moved immediately. This happens because of the order of execution of the scripts. The X position gets set to 0 to stick to the wall in the wall interactor script, but then the move script overrides that data since it's executed after the wall interactor script, making it impossible to stick to the wall. To solve this, we just need to set the script execution order. To do so, go to Edit, Project Settings, Script Execution Order. Click the plus icon, select the move script, and then select the wall interactor script. Finally, click Apply and run the game. Now that the wall interactor ran last, the position value can be properly set to 0 if we are in contact with a wall, without the move script overriding it. Each of the abilities is now independent from each other. If you take a look at the character game object, we can see that it's made up of a rigid-bodied 2D, a controller, and a collision data retriever. Therefore, we can add these components as required when adding an ability. Simply go into each ability and add the collision data retriever and rigid-bodied 2D types. These are things that every ability needs, so we can make sure that they are always present on the game object we want the ability on. This also makes it easier to build characters from the ground up, by just placing the ability we want on them. Now let's start building the foundation of our AI system. First, we'll create a new layer named Platform and select all the platforms in the scene and set their layer to Platform. This will define the areas that the AI can detect. Next, we need to add a way to tell the scriptable object to which game object to apply the behavior. To do so, we'll add a game object parameter to each method, representing the game object to apply the behavior to. If you go back to the Unity editor, you may see errors in the console. Click on one of them and add the parameter to the class methods. Be sure to do the same for the other controllers. For abilities, just add this.gameObject to the controller methods. Once the errors are cleared, run the game to see if everything works as expected. Nothing should change at this point. Next, we'll open the AI controller in the controllers folder and start implementing the logic that will drive the AI. First, we'll declare a layer mask to specify what the AI can detect, a float variable for the distance of the bottom ray and another one for the distance of the top ray. We'll also declare a float variable for the offset of the ray's origin and raycast it to the variables for the bottom and top rays contact information. Now in the retrieve_move_input method, let's fire a raycast. We will first fire the bottom one, which will be in charge of detecting the floor and collect the contact information in the ground info bottom variable. The raycast takes a point of origin, which will be the transform position x of the game object, plus the offset that we want to apply to the origin, multiplied by the local scale of the game object to actually be able to fire the raycast in the direction we are pointing to, and the transform position y. Then it takes the actual direction we want to fire the ray, in this case will be down, since we want to know if a floor is present. Then the distance over which to cast the ray, and the filters for the colliders we want to detect. But you may want to be able to actually see the ray, and to do so, write debug.drawRay. It takes an origin where the ray starts, which is going to be the same of the one above, and the direction we want the ray to go. Make sure to multiply this one by the distance over which to cast the ray. And lastly, the color you want the ray to be. Now we need to write the same thing for the top ray, which will be in charge of detecting walls. To make things faster, just copy the part above and let's change the variable to the ground info top. The direction of the ray will be right, since we want to check what is in front of us, and multiply the direction by the local scale of the game object. This will make sure that the ray will face the same direction that the character is pointing to. Lastly, change the distance to the top distance, then change the direction for the draw ray to right, change the distance to the top distance, and multiply it by the local scale. Now that we have retrieved both values, we can actually use them to check if there is a wall in front of us or there is no floor to walk on. And if that is the case, we make the character turn by changing its local scale by multiplying the current local scale to -1 in the x direction. And we will return the local scale.x, which is the direction the character is supposed to go. Before going back into Unity, set the retrieve_jump_input method return value to false. Back in the Unity editor, go inside the controllers folder of the scriptable objects and select the AI controller. For the interaction layer, first select nothing and then platform. In this way you are telling the AI that it will only detect what's inside the platform layer. Now run the game and change the controller of the enemy to the AI controller. You will see that it correctly detects when there is no floor in front of him and turns. You can increase the X offset to decide how far in front of the player the ray is, and also how long each of the ray are. And if you want to add more functionalities to the AI, you can just write the logic for it inside the appropriate methods. For example, to make the character jump when reaching an elevated platform. We have almost reached the end of the series. Next episode will be the last one, and we will cover how to transition to the new input system.